Hi, Chem Peeps. Today we are going to talk about bond types and how do we know if a compound is going to have a ionic bond or a covalent bond. So looking at my screen, I have a lot of stuff here on the screen. So let's just break it down. Over here, I have some explanation about ionic bonding. And ionic bonding is when one atom donates electrons to the other atom and they form what's called a crystal lattice. So an example of that would be table salt. Sodium chloride gives an electron over to chlorine and chlorine gains it, and that transfer electrons forms that attraction because one of the atoms, let's say the green one, is going to form a positive charge like the sodium when it gives one electron away, and then the little blue one, which is hard to see here, is going to be negative. So chlorine gaining an electron is going to be negative, and then they attract in all directions and form a crystal lattice. Well, how do I tell if a compound is going to form an ionic bond? Well, at a quick glance, I always tell my students, if you have a metal with a nonmetal, it's going to form an ionic bond. If you have a nonmetal with a nonmetal, it's going to form a covalent bond. So let's go over here and look at a covalent bond. In a covalent bond, two atoms share electrons to form a covalent bond. Now, why is it that some atoms will give electrons away and some will gain, and then others will just share? It is because all atoms, except for our noble gases, want to form an octet. An octet is when you have 8 valence electrons in your outer energy level, like the noble gases, and it's the most stable configuration an atom can have because it's the least amount of repulsion energy is to have an octet. And so that's the motivation behind either forming an ionic bond or a covalent bond. Now, that's an eyeball glance. In other words, I could look at an example, and I'm going to give kind of an example here that you probably wouldn't have thought of. Hydrogen is found on the metal side, but it is not a metal. It's just put in that first column here because it has 1 valence electron like the alkali metals that are found there. Now, hydrogen with oxygen to form water is a covalent bond. And so just looking at that, so another example, if I had CO2, carbon and oxygen are both nonmetals. They're going to form a covalent bond. Where over here on the left, we have a metal with a nonmetal. They're going to form an ionic bond. Now, a more accurate way of determining the bond type is to find the electronegativity differences. Now, this chart here you can find in the chapter on bonding, or maybe in the back in the indexes you might find a chart like this. And so this periodic table just lists the electronegativities of all the atoms on the table. Now, fluorine has the highest electronegativity at 4.0, and then we don't have francium down there. Francium, which is below the cesium, it's going to have the lowest. Cesium is 0.7, so francium is 0.7 or lower. And so when we talked about the periodic trends, we know going over and up, the electronegativities increase going across. Well, we can use those electronegativities to determine bond types. So right here, I have an electronegativity difference chart. And so if I have a difference that is between 4 and 2, it's going to be an ionic bond. If I have a difference between 2 and 0.5, it's going to be polar covalent bond. And when I have a difference between 0.5 and 0, it's going to be a nonpolar covalent. Now, why not just covalent? What's this explanation here of polar and nonpolar? We're talking about how nicely or how equally the two atoms are sharing those electrons. And so over here we have a picture of hydrogen and chlorine. Now, hydrogen has an electronegativity of 2.1 and chlorine has a value of 3.0. When we subtract the difference there, we get 0.9, which is going to be a polar covalent bond. Well, that means that the chlorine is hogging the electrons more. And you can see that the cloud around the chlorine is even bigger. So if I look at the bond between hydrogen and chlorine, in essence, the 2 electrons in that bond, are going to sit closer to the chlorine side because chlorine has a stronger pull or a stronger electronegativity on those bonds. Now, if I was to bond let's say, for example, hydrogen to hydrogen, well, it's like playing tug of war with your doppelganger. It's going to be an equal share. The electrons are going to be dead center, and it's going to be nonpolar. So let's look at some examples I have down here of subtracting the electronegativities and some common mistakes that I see my students make, or they're not quite sure or remember what to do when they're on the test. So I'm going to take, if I look at this, I'm going to have carbon bonded to sulfur. So carbon is going to have a value of 2.5. And sulfur happens to have a 2.5. Now, why am I not doubling it since there is a subscript of 2? Well, because I'm only looking at one bond, the bond between one carbon and one sulfur. And so when I measure the difference, it's 0, obviously. And this means absolute value, meaning that if I subtract the two numbers and they're negative, drop the negative. And so this is going to form a nonpolar covalent bond. Chlorine. Chlorine is bonded to itself. Chlorine has a value of 3.0, and so I'm going to subtract it from itself because they have the same value. The difference is 0, and that's going to be a nonpolar covalent bond. Now this one, just eyeballing this one, I have a metal with a nonmetal. This most likely and should be forming an ionic bond. Well, calcium has a value of 1.0, and chlorine has 3.0. So the difference here is going to be 2.0. Now, it's right, this is one of the problems my students have, it's right in between. Is it polar covalent or is it ionic? Well, since this is a metal with a nonmetal, I'm clearly going to say it's going to be ionic. Okay? Now, nitrogen bonded to hydrogen. Now, nitrogen's value is 3.0 and hydrogen's value is 2.1. And so that's a difference of 0.9. So 0.9 is going to be a polar covalent bond. If we look at the last one, we've got 3 different atoms. So basically we have boron bonded to fluorine, bonded to hydrogen, bonded to hydrogen. So I basically have to do 2 differences. So I'm going to take boron minus hydrogen, which is going to be 2.0 minus 2.1, and that's a difference of 0.1, and that is going to be nonpolar covalent, meaning they're sharing those electrons pretty nicely, pretty equally. But I also have boron bonded to fluorine, so that's going to be 2.0 minus 4.0, absolute difference, that's 2.0. Now again, is that ionic or polar covalent? Well, I'm dealing with 2 nonmetals. So I'm going to say this time that it is going to be a polar covalent bond. So this compound actually has 2 types of bonds in it. It's going to have the nonpolar covalent bonds between the boron and the hydrogen, and then it's going to have a polar covalent bond between the boron and fluorine. Now I want to just throw that in something really quick before we finish up. We're talking about bond polarities. In other words, we're looking at the bond between 2 atoms. We are not talking about molecule polarity. So for example, when I draw the Lewis dot structure for NH3 that we did here on the examples, it forms a trigonal pyramidal shape, and because that it has this electrons unshared here at the top, it is not equal pulling over the entire structure. So we have to look at the whole structure here. So this is a polar molecule. So a molecule polarity, you have to look at the whole structure, the bond, you have to look at the difference between the electronegativities between 2 bonded atoms. So I hope this helps. You can find me on TikTok and YouTube at Chem's Chem Chats. Leave me a comment, share and like so others can find this. Talk to you later.